Okay, so hopefully you've taken the quiz 10.4, and you need to be corrected up through 10.3, hopefully 10.4. I don't think I've updated those assignments, so get through the assignments as quick as you can. You need to be working on your labs that we did last time. We actually did the enzyme, the catalyst and catalase. You should be picking up the new one, which is a digestive enzyme lab, and look at it, make sure you understand it, so when you come next time we can do that. Test day started today and goes through the 15th, so if you have any questions, I will be back tomorrow. Make sure you do your pre-test and do all your assignments before you go take that test. So the last part of the chapter that we need to go over is vitamins, and vitamins basically have three characteristics. They're natural components of food, usually present in very, very small amounts, like milligrams or micrograms. The third one, they're essential for normal physiological function. In other words, for growth, reproduction, anything to do with your body working. And when they're absent from a diet, they will cause a specific deficiency. And you'll see it in skin, hair, nails, how the body works, how the liver works, how things work. And we'll talk about a few of those in a few minutes. So again, really quickly, there's three characteristics that vitamins have. They're natural components of food, usually present in very, very small amounts, milligram or microgram. They're essential for normal physiological function, for growth and reproductions and stuff. And when they're absent from the diet, they will cause specific deficiencies. If you need to have the pause the video here, if you haven't got it down, I'm going forward now. So there are two categories of vitamins. One is water soluble and the other one's fat soluble. So let's talk about each one of them for a minute. The water soluble ones dissolve in water. They're needed for energy release, and too many water soluble vitamins, if you have too many of them, they're excreted in urine, no big deal. So if you take too many vitamins in the morning that are water soluble, they just go right through you. Fat soluble, dissolved in fat. They dissolve in fat. They remain in the body for a long period of time. So the four fat solubles are A, D, E, and K. But too many of these can lead to a toxic buildup because they're stored in fatty tissues, the liver and the kidneys. They can cause damage there. So you have to be careful with fat soluble ones. So let's look at a few of the water soluble ones. We've got the B vitamins and C. So the B vitamins are the water soluble and vitamin C. Most of these are found in vegetables and grains and meat and fish and poultry, basically things you eat all the time. You can see on the adult RDA, that's the recommended daily allowance, how much you need. They're all in milligrams. They don't need very much. One of them is microgram, which is the folic acid. That would be 0.4 milligrams. And you see what they're used to function for. So carbohydrate metabolism, nutrient oxidation, protein metabolism, again, nutrient oxidation, and then the folic acid and vitamin B12 are for blood cell formation and the prevention of spina bifida and nerve maintenance. And then vitamin C is an antioxidant and helps with collagen formation. So here's some of the structures of those, and they are found in your book. Also, you can find these structures. There's thiamine, riboflavin, niacin, pantothenic acid, and biotin. Biotin has to do with your nails and hair. You can sort of see the structures going on there. Niacin actually has two forms that you can see here, one with an OH and one with an amine. B6 actually has three forms that are in your body, and depending on what form it's in, depends on what it does with your body. So we got three that we look at there. B12 is probably one of the more complex of all of them, and then folate is also pretty complex. So the other B vitamins, and I think we'll see C on the next slide, are not quite as complex. But you can see that B12, in the center of B12, it actually has a cofactor of cobalt in the center here. The others do not. So this is pretty intense here. We also have a phosphate down here, and lots of amine groups. Here's vitamin C. Vitamin C is pretty straightforward. It sort of looks to me like a guy. Here's his head. We'll put some hair on him. And he's got a big something, a bat or something, and he's swinging. So anyway, that's what it looks like to me. So vitamin C, he's antioxidant. He makes sure that oxidation does not take place inside the body, helps things work. We can actually get it from glucose, vitamin C. So you can sort of see the synthesis there of L-ascorbic acid, dehydroxyl. So what happens when we're deficient in some of these B vitamins and C vitamins? So B6, you end up with dermatitis, you end up with skin disorders, kidney stones, nausea, cracks in the corners of your mouth. You've probably seen people like that. B7, a lot of nausea, vomiting, muscle pains, anemia, fatigue, loss of appetite, and a lot of heart abnormalities. If you're deficient in vitamin B9, this is what causes birth defects. So this is folic acid. And so the people that are pregnant, they say they need to make sure you get enough folic acid. It also can cause anemia and diarrhea. B12, also fatigue and anemia, a lot of neurological disorders, and problems with your bone marrow. Vitamin C, if you are deficient in this, wounds don't heal very well. You have loose teeth and bleeding and swollen gums and muscle weakness. So you see there's a lot of deficiencies that can cause a lot of problems. So let's look at B1. If you're deficient in B1, you get what's called beriberi. And this B1 vitamin is needed for the enzymes of carbohydrate metabolism. We've been working a lot with enzymes. But in this disease, the calf muscles become tender and you get vomiting, tremors, convulsions, and loss of appetite. Where you can get B1 is cereal like wheat, oil seeds like groundnut, milk, fish, and meat. So let's talk about the fat-soluble vitamins here for a second. This is A, D, E, and K. Remember from earlier, the slides, if you have too much of these, it can actually be toxic to your body because they are fat-soluble. They're stored in the kidneys and the liver. So vitamin A, you do need it. It's for vision, reproduction, bone health, and immune system, and skin. Vitamin D is also needed for your bones. It strengthens them. It helps with your calcium absorption into your bones and the immune system. E is the immune system and flushes toxins. And if you believe some things on the internet, it's also for heart health. Vitamin K is for blood clotting and bone health. And you got to be careful not to get too much K because that can actually mess with your heart. All right, so these are what the lipid-soluble or fat-soluble vitamins are. Remember, lipid's just another name for fat. And you notice that we don't have any cofactors on any of these. There's no metals. They usually have at least one ring, and they've got a long tail of some sort. So the fat-soluble vitamins will have a long tail. And that makes sense because remember, long tails or long carbon chains are fats, and that would make it fat soluble. So here's what's happening when we have deficiencies in vitamin A. You'll end up with night blindness, myopia, dry eyes, and scaly skin. And then on the far side of the resources, those are the places that you can get vitamin A. If you're low on vitamin D, you get rickets. Vitamin E, you have fertility disorders. Vitamin K, blood clotting doesn't occur, so you have problems when you get cut. So a lot of these, if you've noticed, both fat-soluble and the water-soluble, you can get from the same sources. A lot of people say beta-carotene or eating carrots will help you with your sight. And the reason is if you cleave beta-carotene in the middle at site 15, you actually get 2 vitamin A molecules. And that's why they say it's good for your eyes, because you can get vitamin A, twice as much vitamin A out of a beta-carotene. Okay, so let's look at how water-soluble and fat-soluble vitamins what about each of them? So the absorption, water soluble, they go right into the blood. For fat soluble, they first have to go in the lymph and then to the blood. So they have to be integrated. Water soluble, they travel freely through the body, but fat soluble require protein carriers. Storage of water soluble vitamins, they circulate freely through the water-filled parts of the body, so there really is no storage. But the fat-soluble vitamins, so on the water-soluble vitamins, you got to keep getting it into your system. There's no storage. On the fat-soluble, it's stored in cells associated with fat. Like I said, usually the liver and the kidney. So you have to be really careful because you don't want to store too much because then it becomes toxic. Excretion, water-soluble, right through the water, right through the kidneys and out. Fat-soluble don't like to be excreted. They tend to remain in your fat stores. That's why they become toxic. So you have to only take what you need. You can reach toxic levels with water-soluble, but that's when you're consuming supplements like crazy. Then you can reach toxic levels. But it's real quick and easy to get out of toxic levels by doing flush with lots of water. However, toxic levels with fat-soluble vitamins are harder to get out of the system and tend to be more long-term toxic to the body. So, requirements. On water-soluble vitamins, you need it every 1 to 3 days. So you're constantly needing to eat vitamins from the B's and the C's. For the fat-soluble, it's weeks or months. That's how often you need them. You don't need a lot. So you don't need to eat carrots for vitamin A every single day. You only need it every once in a while. Okay, so this gives you a good idea of the difference between water-soluble and fat-soluble. And you need to know the difference between those two and how they're stored and what the toxicity is and how much we need. Now remember, vitamins, we only need milligrams or micrograms amounts. They're very, very small. Okay. So then we go talking about coenzymes. Coenzymes are, they act as group transfer agents. So if you look at the picture there, you can sort of see the coenzyme gets the thing together with the enzyme and then makes the product. So there's two different kinds. We've basically been talking about the rest of the chapter. We've been talking about metabolite coenzymes. They're synthesized from common metabolites. What we're now going to be talking about is vitamin-derived coenzymes. So in order for an enzyme to work, they've got to have this vitamin that is a coenzyme with it to make it work. So vitamins can't be synthesized by mammals, but we have to obtain them from our nutrients, the things that we eat. Okay, and that's all we're going to talk about. So that's the end of the chapter. Remember I told you we've actually already done both of these two labs, so you should be doing the write-up on these. The lab that you're going to be getting as you come in, or you got as you came in, was digestive enzymes at work. You need to make sure that you are reading that, getting it put into your lab notebook, and be ready for when I come back and we'll do that lab. If you didn't finish one of these two labs, you'll have to finish it next time as I come back on Monday to finish that. All right, so work on getting your labs written up, get your other lab in, and work on your assignments, get your other assignments corrected and in, and we'll see you later.